So if you've taken Algebra 2, chances are you're fairly familiar with parabolas. And I'm assuming what you did was you utilized x-intercepts and plugged in some points to graph them. So for example, let's say you had the function f of x equals x squared minus 7x plus 10. You'd factor this and say, that's equal to x minus 5 times x minus 2. And so the x-intercepts of the graph are x equals 5 and x equals 2. So you draw the x-intercepts and then you'd plug in various points and you'd figure out the graph. Looks something like this, and to figure out the exact vertex you probably use the mnemonic negative b over 2a. So if this function's of the form f of x equals ax squared plus bx plus c, and the x coordinate of the vertex is negative b over 2a. And so in this case that equals 7 over 2, and you'd plug in 7 over 2 here to figure out the y coordinate. So we just write f of 7 over 2 equals, we'd plug into this equation, so 7 over 2 squared minus 7 times 7 over 2 plus 10. If you work out the arithmetic correctly or plug it into your calculator, you should get negative 2.25. This is the same thing as negative 9, or sorry, 9 over 4. So it's going to be somewhere here. So this is about, the x coordinate is about is equal to 3.5 here. So 7 over 2. And the y coordinate is negative 2.25. So negative 9 over 4. So I'm sure you've gone through that process many times. But here we're going to look at more of the formal definition of a parabola and figure out the equation that comes out of that formal definition. So a parabola in general is the set of all points x, y equidistant from a focus, which is this point, and a directrix. So let's say you're looking at this point, x1, y1. Well, this seems to be about the same distance from this focus as the directrix, and I know I didn't draw it perfectly, but you can kind of see that. When you're looking at the vertex HK here, seems like it's the same distance from the focus as it is from the directrix. Looking at this point out here, same distance from the focus as from the directrix. So knowing that distance, the equality of the distance from the focus and directrix is preserved for all points, how can we come up with a general form of an equation of a parabola? Well, that's the subject of this video. But before we derive that equation, I'm going to point you to some general features of the parabola. This is the vertex here, and it's labeled HK. This is the focus. It's HK plus C. So the x coordinate is the same as the vertex, while the y coordinate is C above the vertex. And this is the case for an upward opening parabola. And the directrix is the line y equals k minus c. So it's just C y units below the vertex. So you can kind of see that the vertex is in the middle of the directrix and the focus. Okay, so let's say we have a general point x, y here. We know that based on this definition of a parabola, this general point x, y is going to be equidistant from this focus hk plus c and the line y equals k minus c. And we're taking the perpendicular distance to this line here. So the point we're going to be looking at here is x comma k minus c, because this line is the line y equals k minus c, so it takes on all values of x. But when we're looking at this perpendicular distance, we're concerned with the value with the point x comma k minus c. So these two distances are equal. So using the distance formula, we can write an expression for this distance as well as this distance and note that they're equal. So the distance between the focus and xy is, well, we're going to be using the distance formula, so x minus h squared, and this is square root of all this stuff, so x minus h squared plus y minus the quantity k plus c squared, so y minus in parentheses k plus c squared and the square root of all of that stuff. What about the distance between this point x, y and the directrix? So this distance is just, see, the x coordinates are the same, but for sake of completeness, I'll just write out the whole distance formula expression. X minus the square root of x minus x squared, so x minus x, plus y minus k minus c, so the quantity k minus c squared. Well, this is the same thing as just the square root of y minus k minus c squared. Okay, so we can equate these two because remember, for a parabola, any point on the parabola is equidistant from the focus and the directrix. So let's equate these two. So we've equated both of these expressions. You'll see we have square roots on both sides. We can square both sides and get rid of the square roots. So you'll see here on the left side of the equation we have a pair of binomials, each squared, and the sum of a pair of binomials, each of which is squared. And on the right side we have just the square of a binomial. So I'm going to go ahead and expand both of these sides now. So I went ahead and expanded, and note that I left this x minus h, the quantity squared, as is, because our final expression for the general form of a quadratic equation contains this x minus h, the quantity squared expression, as it is. So I left that alone, but I expanded this and I expanded this. You'll see that there's a little bit more work to do because here we have a negative 2y times k plus c, and here we have a binomial squared. Similarly, here we have a negative 2y times k minus c, and here we have another binomial squared. So I'm going to have to go ahead and expand those as well. But before I expand those, we're going to note that there's a y squared on this side and a y squared on this side, so those cancel. And I'm going to add both of these expressions, or I'm going to add 2y times k plus c to both sides, so effectively bringing it to the other side. And I'm going to subtract k plus c, the quantity squared, from both sides of the equation. So that's going to effectively bring negative, or the additive opposite or negative of k plus c, the quantity squared, to the other side of the equation. Okay, so when I've added this to both, or I've added 2y times k plus c to both sides and subtracted k plus c, the quantity squared, from both sides, this is the expression we end up with. So you have this 2y times k plus c term on the right side, and I've next to it written the existing minus 2y times k minus c term. Here, this term has been brought to the other side as well, so we have minus k plus c, the quantity squared, next to the existing k minus c, the quantity squared term. Kind of running out of space here, so I'm going to rewrite that in another location on the page. Okay, so when we expand this expression out, we get 2yk plus 2yc minus 2yk plus 2yc minus k squared, and minus 2kc, because this would be a plus 2kc, but there's a minus sign there. Minus c squared, because this is a plus c squared, but there's a minus sign in front of it, becomes minus c squared. Positive k squared, minus 2kc, and c squared. You notice I've drawn slashes through it to cancel out terms that cancel. So you have a plus c squared and a minus c squared, those cancel. You have a plus k squared and a minus k squared, those cancel. We have a plus 2yk and a minus 2yk, those cancel. So what we're left with is 2yc plus 2yc. It's going to be 4yc, and minus 2kc minus another 2kc. So that's going to be minus 4kc. So when we factor out the c, or 4c I should say, we're going to have equals 4c times y minus k. So this is x minus h, the quantity squared, equals 4c times y minus k. If we divide both sides by 4c, get y minus k is equal to 1 over 4c times x minus h, the quantity squared. Solve for y. I get 1 over 4c times x minus h, the quantity squared, plus k. So either of these two equations here are acceptable forms of the general form of a quadratic equation. Now let's go through and see what these letters mean here. So you notice we have h and k. hk is the vertex of the parabola. So, let's say if this were like, I don't know, y equals 2 times x minus 5 quantity squared plus 8, you can see that the vertex is, in this case, 5, 8. But what about this 1 over 4c term? Well, if you look at this graph here, the vertex is hk, but the focus is h comma k plus c, and the directrix is a line y equals k minus c. So it looks like c is the distance between the focus and the vertex, as well as the distance between the vertex and the directrix. Okay, so here we have y equals 1 over 4c times x minus a, so quantity squared, plus k. So let's say you're given this equation here. What does this tell you about the focus and the directrix? So here we know that this is equal to 1 over 4c. So 2 equals 1 over 4c. So what's c? Well, c is 1 over 8, right? And this positive leading coefficient, or I should say this positive value for this term in front of the x minus 5 squared, indicates that this parabola opens upward. And hopefully you'll realize that when you see that there's only one x squared term here, and so when you go ahead and expand this binomial and you multiply by 2, your x squared term will have a leading coefficient of positive 2. Okay. Anyway, this c equals 1/8. So what does that mean? Well, if you go back to this graph here, you can see that the focus is going to be at h comma k plus c. So we saw that the vertex is at 5 comma 8. Well, that means the focus here is at 5 comma 8 plus 1/8. Or it's 5 comma, I guess that would be 65 over 8. Now what about the directrix? Well, the directrix is the line y equals k minus c. So if k is 8 here, then we know the directrix, I'll just write it here, it's going to be the line y equals k minus c. K is 8, right? And c is 1/8. So 8 minus 1/8. This is going to be 63 over 8. So hopefully that gives you some insight into how we got this equation of a parabola from the definition, the mathematical definition of a parabola being the set of all points equidistant from a focus hk plus c and a directrix yk minus c.